jump into the completing the square method, let's take a moment to talk about what a perfect square trinomial means. Our goal in doing these problems is to get a perfect square equal to a constant. Once we have that accomplished, we can go ahead and use the square root property. So our goal is to get this problem to look like the last set of problems looked before we solve them. So we need to first talk about what a perfect square trinomial means. If you've got a trinomial that looks like, let's say, x squared plus 10x plus 25, and I ask you to factor this, you go ahead and do that. Pause your video, factor that, and see what you get. Okay, so your factored version should look like x plus 5 times x plus 5. You'll notice that you're multiplying the same factor by itself. This can also be written as x plus 5 quantity squared. So a perfect square trinomial is any trinomial that can be factored into a perfect square, as we have here. This trinomial is not a perfect square trinomial, but we can turn it into one by doing some special techniques. So the completing the square method gives us the steps that we need to turn this, at least this part, into a perfect square trinomial. So let's see how we can make that happen. The first thing we want to do is we need to isolate just the x squared and the 6x. So the two terms that have x, we need on one side of the equation by themselves. So we'll first subtract 7 on both sides. We're also going to be adding a number to both sides of the equation. So I'm going to go ahead and put a blank on both sides. I'm going to subtract 7. And I'm going to put a blank on the other side because I need to add a number here to turn this piece into my perfect square. Alright, so all I've done so far is I just subtracted 7 on both sides, and because I know I have to add a number over here, I put the two blanks so that I remember to do it to both sides. I hope that's clear. Do you see why I would, this part is probably very obvious, hopefully, that you know that you have to add a number on this side. But if I forget to add it over here, I'm going to be messed up because my equation is no longer balanced. So the blanks just help me remember to keep the equation balanced, to add the same thing to both sides. Now let's talk about what number needs to be added. In order to create a perfect square trinomial, so that when I factor it, it's the same thing times itself, what number do you think should be in this spot? We want a 9 here. The way we figure that out is we look at this number. We take half of 6 is 3, and then if I square 3, I get 9. And of course, add the 9 on both sides. So you put the same number in both blanks. But do you see how that if you factor this, how is this going to factor? Take a moment and factor it. You should have x plus 3 times x plus 3. And on the right side, negative 7 plus 9 gives us a 2. And because this is the same thing times itself, we have a perfect square. X plus 3 quantity squared equals 2. We are now ready to apply the square root property. So again, because we've got a perfect square on the left and a constant on the right, we can go ahead and take the square root of both sides. So we'll get x plus 3 equals, remember to do plus or minus the square root of this constant 2. And we can subtract this 3 in order to get the x by itself. So subtract 3 on both sides. We've got x equals negative 3 plus or minus square root 2. This is one way of expressing our answer. Again, you'll probably also need to write it as a solution set. So in the curly braces, we just list the two answers. So we've got negative 3 minus square root 2, comma, negative 3 plus square root 2. Okay, example 3, part B. We're still asked to solve by completing the square. We've got 2x squared minus 3x minus 4 equals 0. All right, one thing that's very important to notice about this problem in relation to the last problem that we just did is that the numerical coefficient on the x squared term is not 1. That's going to give us a little, just a little extra work to do. In order to fix this, well, before we can complete the square, that first coefficient must be 1. So how can we make that a 1? Well, let's just divide both sides by 2. So we're going to divide everything on both sides by 2. That will give us x squared minus 3 halves x minus 4 halves, or 2. And of course, 0 divided by 2 is still 0. So now we're going to complete the square for x squared minus 3 halves x minus 2 equals 0. So we still proceed the same way as before. The constant needs to be added to both sides, and when we do that, we'll put in our 2 blanks. So we've got x squared minus 3 halves x plus blank. Add the 2 to both sides and put in the second blank. All right, how do we fill in this blank? We need to, again, just like we did in the last problem, if you recall, we needed to find half of this number, and then we had to square it in order to put it into the blank. What is half of negative 3 halves? That should not be difficult for you to figure out. 1/2 of 3 halves, that means 1/2 times 3 halves. 1/2 times 3 halves. We talked about multiplying fractions. You multiply straight across the top, straight across the bottom. So that is 3/4. Okay? So half of 3 halves is 3/4. And then what goes into the blank, if you recall from the last problem, or you can also look at your steps in the notes. We take half of this number, which we've done, and then we square it to put into the blank. So if I square 3/4, I'm going to square the 3 and square the 4, so that gives me 9/16 in the blank. And the same number on the other side, 9/16. At this point, it's understandable to be concerned about having to factor something that has all of these fractions in it, but it's really not as bad as it seems. The number that we got in this step where we took half of the middle term, that 3/4 is the number that we will use when we factor. So because this number was 3/4, we can easily factor the problem. It becomes parentheses x minus, the minus is because we originally had the negative 3 halves. So this is actually negative 3/4. X minus 3/4 times x minus 3/4 equals, and then we have to figure out what that is over there. But as far as the factoring piece of this, the number that you got when you took half of this middle term, but before you squared it, the 3/4 is the number that goes in here and here. And again, it's negative because we were really doing half of negative 3/4. Excuse me, half of negative 3 halves was negative 3/4. Now, what is 2 plus 9/16? Again, this should not be that hard for you, but if you need to use a calculator, that's fine. 2 expressed in terms of sixteenths is going to be 32/16. Okay, and then 32 plus 9 gives me 41. So 41/16 is the number over here. And now we can go ahead and write this as a perfect square. So we've got parentheses x minus 3/4 quantity squared equals 41/16. Slide all this up so you can see better. All right, so what do we do at this point? Well, we've got the perfect square on the left and the constant on the right. Let's go ahead and take the square root of both sides. So the square root of a perfect square just gives us the inside. So x minus 3/4 equals, and when you do the constant, remember to do plus or minus the square root of 41/16. Okay? Square root of 41 over 16, that can be broken apart. So we've got x minus 3/4 equals plus or minus the square root of 41 over the square root of 16, and you should know that the square root of 16 is 4. We're almost done. We need to get x by itself, so we want to add 3/4 on both sides. So we have x equals 3/4 plus or minus square root 41 over 4. How do I know that I'm finished with this? Well, think about what's inside your radical. 41. Is there anything that can be done to break down a 41? Can you factor 41? 41 is a prime number, so there's nothing that can be done to break it down any further. There are no perfect squares that you can take out 41, so that's as far as we can go with this answer. So if you're doing this on a test or a quiz in class, something on paper in class, you can leave your answer just like this, and that's fine. In my math lab, again, they're probably going to want you to write this as a solution set. So just they'll have the curly braces all ready for you. So you'll say 3/4 minus square root 41 over 4, comma 3/4 plus square root 41 over 4. And that'll be it. Our last method for solving quadratic equations that we're going to discuss today is the quadratic formula. The quadratic formula is what you would obtain if you were to take the original quadratic equation in the standard form that we talked about at the very beginning of this section. If you were to solve this equation for x, it would give you the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, and sorry, that's kind of messy there. So that's how and you can play around with trying to solve that for x if you like. That's where the quadratic formula comes from. The quadratic formula will solve any quadratic equation that we are needing to solve. There really is no disadvantage to using the quadratic formula, other than it might be a little bit longer to simplify towards the end of the problem. All right, but that's what the quadratic formula is, and we're going to start looking at some examples of how to solve using this method. In order to solve an equation using the quadratic formula, you first need to be able to identify what numbers need to go in for the specific letter, the A, B, and the C in the formula. The A, the B, and the C correspond to your coefficients in the standard form. So the coefficient on your x squared term is your A. In this example, A equals 1. B is the coefficient on the linear term, or just regular x. So B is 8. C is the constant, 6. So we'll just substitute each of these numbers directly into our formula. So we'll have x equals negative b will be negative 8 plus or minus the square root b squared. So that's 8 squared minus 4 times a is 1, c is 6. This is all over 2 times a, so 2 times 1. So getting it into the formula is easy. Simplifying it might get a little bit, it can get a little bit messy when you're simplifying these sometimes. We've got negative 8 plus or minus the square root. Let's go ahead and simplify the inside of that radical as far as possible. 8 squared gives me 64. And then negative 4 times 1 times 6 is negative 24. So 64 minus 24 is 40. And this is all over 2. I need to simplify my radical as far as I can. What can I do with square root 40? If you think about, is there a way that you can write 40 so that it has a perfect square? You can do, I'll let you think about that for a moment. You can pause if you need to. Okay, let's write 40 as 4 times 10. So we've got x equals negative 8 plus or minus the square root of 4 times 10 over 2. Now we can take the square root of 4, giving us 2 on the outside. So x equals negative 8 plus or minus 2 square root 10 all over 2. All right. We also have to be careful that everything is completely simplified. With this being a fraction, we've got a common factor between the -8, the 2, and this 2. They all have a common factor of 2, so we need to simplify that further. If you want to think of this as breaking it apart, which is a way that we handled in previous problems, we would break these apart because the number in the denominator was just a single term. And you can do that here. You can say that this is -8 over 2 plus or minus 2 square root 10 over 2. And of course that simplifies as x equals -4 plus or minus 1 times the square root of 10. So this is your answer. Again, if you're doing this on a test in the classroom, you can leave your answer just like this. In the homework, the solution set would be -4 minus square root 10, comma, -4 plus square root 10.